This narrated PowerPoint focuses on the Doppler formula. Doppler formula problems really have no creativity. They're all basically the same. They all sound something like this. The 21 centimeter radial line is observed in a nebula at 20.5 centimeters. Is the nebula approaching or receding? What is the radial velocity? Now, it could be a nebula, could be a comet, could be a star, could be a planet, could be a satellite, could be a flying car. Actually, we have one of those now going out by Mars, aren't we? Thank you, Elon Musk. The point is that something is moving in space, and we want to figure out how fast it's going and whether it's approaching or receding. And what you're given in the problem is two wavelengths. If we look at the formula sheet, there is only one formula that has two wavelengths in it. And so it's easy to figure out which one is the right formula to use. It's this one. And what we're trying to find is the radial velocity. The speed of light is just a constant. I mean, you're given the speed of light. Speed of light is right here. And then the two wavelengths are given in the problem. So it's actually a fairly simple thing to solve if you just recognize that it's always going to be the same thing. The only tricky part is reading the problem carefully to figure out which is the apparent wavelength and which is the true wavelength. So we need to identify the different variables. So let's look at the problem again. It says the 21 centimeter radial line is observed in a nebula at 20.5 centimeters. That's all you need to look at. Look at the wording. See where it says here, is observed? Something that is observed is the apparent wavelength. Now this could have said, is seen at, is found at. The point is, it's not what it normally is. So the apparent wavelength is going to be the 20.5 centimeters. The true wavelength is the wavelength that it normally is, say, in a laboratory. So see how it says the 21 centimeter radial line? This is what it normally is. And so the true wavelength is 21 centimeters. The apparent wavelength is what it is observed at 20.5 centimeters. We've already done the hard work here. So now we're going to plug it into the formula. So the true wavelength divided by the apparent wavelength is all this stuff over here. So I'm going to plug in 20.5 centimeters divided by 21 centimeters on the left-hand side, and I'm not going to worry about this stuff on the right-hand side at the moment. So if I divide 20.5 centimeters by 21 centimeters, the first thing you'll notice is that the centimeters cancel. That's great. And so now we're left with, on the left-hand side, 0.976 equals 1 plus this stuff over here. Now here's another place where people make mistakes in the algebra. You want to get all of this stuff over here by itself. You want to isolate it. So you have to get rid of this 1 here. You don't multiply or divide that 1. See how it's an addition problem? You need to subtract the 1 from both sides. So if you subtract 1 from 0.976, you get negative 0.0238. And that is equal to the radial velocity over the speed of light. The speed of light, again, is 300,000 kilometers per second. So negative 0.0238 is radial velocity over 300,000 kilometers per second. So now we're going to cross multiply. So this times this equals the radial velocity times, well, what does it have to cross multiply with? Well, you can imagine the number 1 here in the denominator on the left-hand side, if that makes it easier for you. And so now we just multiply these two numbers together, and that gives us the radial velocity, and you end up with negative 7,143 kilometers per second. This negative sign here is important because remember the problem asked you whether or not this nebula was approaching or receding. Now remember that if the wavelength is getting shorter, then that is a blue shift. It is coming towards you. It's approaching. Remember that the wavelength should have been 21 centimeters, but it is seen at 20.5. So indeed, it is getting shorter. It is a blue shift. This negative sign reminds us that it is coming towards us because it's very bad. It's negative when something is coming toward us. So this is indeed a blue shift, and this nebula is approaching. If we had a positive number here, well, it's positive, it's good when something is going away from you. If the wavelength is getting longer, let's say instead of being observed at 20.5, it was seen at 22 or 23 centimeters, then we would have had a positive number, and that would be traveling away. It would be redshifted, it would be receding, and that would be positive.